So today we are going to see the further part of digital electronics, and the first thing that we are going to cover is De Morgan's theorem. De Morgan's theorem statement is this: a plus b whole bar is equal to a bar dot b bar. There is an alternative statement also, that is a dot b whole bar is equal to a bar plus b bar. So the theorem can be proved with the help of a truth table also. So if you look at this one statement, the first one, that is a plus b whole bar, is the NAND gate. A plus b whole bar, that is a NOR gate, which is equivalent to AND gate having inverted inputs a bar and b bar. The second statement, a dot b whole bar, is a NAND gate, which is equal to OR gate having inverted inputs a bar and b bar. Okay, so for proof we have this statement: a bar dot b bar, a dot b whole bar is equal to a bar plus b bar. So first it is solved for a dot b whole bar. A dot b whole bar is a NAND gate and a dot b is a AND gate. In first column we have got input A, in the second column we have got input B, in third column we have output AND gate, output of an AND gate, a dot B, and this is inversion of output of this column. So this is your NAND gate and this is your AND gate. Okay, so for 0 0 output of AND gate is 0, for 0 1 and output of AND gate is 0, 1 0 AND gate will give you 0, and only for 1 1 output of AND gate will be 1. So what all we have to do is take the inverse of this column and fill it in this particular column. So 0 becomes 1 in the first row, then 0 becomes 1 in the second row, 0 becomes 1 in the third row, and 1 becomes 0 in the fourth row. So this is how we get fourth column. So a dot b whole bar is found with the help of this truth table. Now we will find a bar plus b whole, a bar plus b bar. A bar plus b bar is actually a OR gate which has got two inputs, a bar and b bar. So the truth table is prepared here. We have to have two inputs, a and b, then take its inverse or then take its complement, a bar and b bar, and then find out its OR operator, output of an OR operator. So here we have a and b. So a is 0, a bar is 1, b is 0, b bar is 1. Likewise, this input a and b is inverted here. All inputs are inverted, and then we find the OR of this column only: a bar, b bar. Okay, so what OR says you? OR says you that if any one statement is true or all of the statements are true, then output will be 1, otherwise 0. In other words, if all statements are 0, all statements are false, then only its output will be 0, otherwise it will be 1. Therefore we have this one, rows and columns. Only this row will produce 0 and rest of all rows will produce 1 as per rule. This is how we got the truth table of a bar plus b bar. If you look at this column and if you look at the other column, which is this one, both are same. This column A bar plus B bar, and this one A dot B whole bar, both of them are equal. Therefore we can say that A dot B whole bar is equal to A bar plus B bar. The first statement of De Morgan's theorem is proved. The second statement of De Morgan's theorem is this: A plus B whole bar is equal to A bar dot B bar. The procedure is same. In this case we have a NOR gate, so you have to find the output of OR gate first, and then take its complement, and this one is your AND gate having two inverted inputs, A and B, right? So let us look at the truth tables. The truth table, this one, this one is for left side of the equation, A plus B whole bar. The inputs are given A and B. First we found A plus B, that is OR, and then we will take the complement of OR. So what is there? For 0 0 output will be 0 and rest of output will be 1, right? This is OR gate, and simply we'll take the complement and we'll find NOR gate. So the output is 1 0 0 for A plus B whole bar. On the other side of equation, we have this truth table. We have two inputs A and B, then we have to take the complement of A and B individually and then find out the response of A AND gate. Now inputs are given and their inverses or complements are also given. These are the complements, these are the original inputs. This is response. Okay, so by rule, what is the output of AND gate? AND gate will produce 1 if all inputs are 1, otherwise it will produce 0. Therefore, if you look at the first row, the input is 1 1, then only output is 1, otherwise it is 0. Okay, so this is how we have this response. In this response, in the final column we have got 1 0 0. On the other side of equation also we have got 1 0 0 as the output column. Therefore both of the sides are proved. That's why we can say A plus B whole bar is equal to A bar dot B bar. This is how De Morgan's theorem is proved.